Hello. Today I'm gonna be talking on the techniques of integration. As you know, we have so many techniques of integration, but today I'm just gonna take the basic techniques. As we all know, integration is the same thing as derivative. It's just undoing what you did with derivative. So let's see how we go about it. But today I'll be going with substitution method. That's what we use today. We have a question here. It said evaluate the integral this question. So the method I'm gonna use is called substitution. That's what I'm gonna use. So basically what we need to do is we have two functions of x, two equations in terms of x. We have e dx and 1 minus e raised to minus 2x square root of it. So you have to find which of these two would be your u. And the best way I do it is I usually make the equation with more expression in terms of u, in terms of x to be my u. That way it will automatically cancel out the other equation. So that's what I'm going to start with. So I'm going to start with making, I'll say let u equals e to x, e raised to negative x. Now finding the u dx, that gave me the same thing, remember? Then I'll multiply this by derivative of the function of x, which is, if you find the derivative of negative x, it gives you negative. So that's it right there. Now with respect to dx. So if you look at this expression, we have dx there. So there are two ways of doing this. You could either look at this expression here and find it in this question. If you look at the question, we have dx, we also have the x. Do we have e to the negative x? Not really, but what we can do is, this one is to the positive x. We can also rearrange it. That's one way. Another way is just automatically, you see the x here. Try to find what is the x from this expression, which is the way I'm going to go with. So from here, I can see that my dx is equals to my du divided by negative e to negative x. So I'm going to plug in this here. I'm going to put it into this expression. When I see the x, I just write du e of that, okay? And don't forget, u is e to negative x. So what I do now is I'm going to rewrite this expression as integral of, instead of the x, I'm going to be having, let me write somewhere here. Dx is now du over, this thing has been multiplied by this, negative e minus x. Now, I have this here, don't forget, I put it here also. This square root. Then I have 1 minus, this is like my ex is my u, so that means I'm having u raised to 2. So this is like 1 over this. Now what we have is this expression here can multiply this. Remember from your law of indices, when you have x raised to a power multiplied by another x raised to maybe b, the answer will be, you just add up the powers, 1 plus 8. So here we have e dx, and we also have e raised to minus x. So when I multiply them, I will have my ex multiplied by my e raised to minus x. I just add up the powers. So I've got x plus minus x. I should have x raised to 0, which is 1. So automatically this cancels out. So the new expression becomes the integral of du over square root of 1 minus u squared. So everything is now in terms of u. So what I need to do is just think of what do I differentiate to give me square root 1 over square root of 1 minus u squared. That takes you back to your x sign. So I'm going to say when I integrate 1 over root 1 minus u squared, I will have, oh, don't forget the negative sign, please. There's a negative sign here. I'll put it back here. So I will have negative x sign of, this is an x sign, of u. Then you add a constant. So I got to plug in back my u. Remember, u is e raised to minus e. U equals e raised to negative x. So I just change it back there. So this answer is simply negative x sign u is e negative x plus my constant. So that is the answer of what we're looking for. So if you have any problem, just let me know. Comment. You can send an email to me at moses2real@hotmail.com. Thank you. Oh, sorry. You can see that? All right. So now you see everything. Thank you.